Algebra 1 students, welcome back. Today we are going to be doing direct variation. And as usual, the first slide is just some definitions that you guys definitely need to be conscious of. And make sure, just to point out, you guys know this equation right here. We're going to be using it a lot today, so make sure you know it. So, for the first ones, we're going to graph each direct variation equation. So for the first one, y equals 5x, and we can say this is our slope, so it would be 5 over 1. So to do this on our graph, we would go up 5 and over 1. So 1, 2, 3, 4, 5, and over 1. So that's one of our points, and we need at least 2 points to make a line. So to get the other point, we can either go up and right, or we could go down and left. 1, 2, 3, 4, 5, and over 1. So this would be our second point, and then we just connect them. And make sure you guys put arrows at the end of your lines, okay? Sorry, that's not a very good line, but you guys can understand it a little bit. So for the next one, since it's a negative, we can't forget our negative, so it'd be, we can go down 2, 1, 2, then right 5. 1, 2, 3, 4, 5. Or we can go up 2, 1, 2, and left 5. 1, 2, 3, 4, 5. Either way, it'll still give us a negative slope. So all we do is connect those 2 points. And when you guys connect them, make it look a little bit better and actually go through the line. So this is how you would graph direct variation equations. And I want you guys to notice, I know it's really badly drawn, but if you look, these should both go directly through the origin of 0, 0. So I know they're really badly drawn, but they should go directly through. That's what a direct variation is. It has no y-intercept, so it does not move up or down at all. Okay? So keep that in mind when we do the next problems. Okay, so for the next one, determine whether that each equation represents a direct variation. If it does, find the constant of variation. So the first thing we need to do to figure out if it is a direct variation is we need to solve for y. And then when we solve for y, we have to see if we have a y-intercept or not, or if it's in the form of y equals kx. Okay? So let's solve this one. So divide by -8, and we get y is equal to 2x over -8, and that will reduce to be y equals -1/4 x. 2 over 8, -8 is -1/4. So we have to ask ourselves, is this a direct variation? And since it does not have a y-intercept or a plus anything, means it is direct variation. So yes, this is direct variation, and our k value, which is the constant of variation, is equal to the k, and our k value is -1/4. Okay, so for number 4, let's do number 4. We first always need to start by solving for y. So to get y by itself, we need to subtract 3x. And then to get y by itself again, we need to divide by 4. And you have to divide everything by 4. So y would equal -3x over 4 minus 5 over 4. And we have to ask ourselves, is this direct variation? And when you look, in the form of y equals kx, it does not have a plus anything, but this one has a minus 5, 4, so no, this is not direct variation. Okay? So it has a y-intercept, so you cannot have direct variation. Let's go on to the next ones. So for these ones, suppose y varies directly with x. Write a direct variation equation that relates x and y. Then find the value of y when x is equal to 8. Okay, so for this one, y is equal to 10 and when x is equal to y. So we're going to use the form, just like the last slide, y equals kx. So y, let's just plug in the numbers. Y is equal to 10 is equal to, and then we don't know our k, so we just put in k, but we know our x is 2. So to get k by itself now, we just need to divide by 2. So 5 is equal to k. So our direct variation equation will be y equals 5x. So this is our equation, direct variation equation. And then if you look at the directions, it says then find the value of y when x is 8. So when x is 8, so let's just plug in 8 for x. So 5 times 8. I'm just plugging in an 8 right here. So what's 5 times 8? And hopefully you guys know is 40. So y would equal 40 when x is 8. Okay, let's do number 6 together. So we use this form again, y equals kx. So let's just plug in our numbers. We have 6 is equal to, we don't know our k, and our x is 18. So to get k by itself, we divide by 18. And 6 over 18, hopefully you guys noticed, 6 goes into 18 3 times, so it'd be 1/3 is equal to k. So we found our k, so our equation will be y equals 1/3 x. So this is our equation. And then it asks when x is 8, so y is equal to 1/3 times 8. And then when you multiply across, we get y is equal to 8/3. So when x is 8, our y is 8/3. I want you guys to pause this, do number 7 on your own, and then we'll come back and make sure we have the same answers. Okay, I'm back. You can see what I did. I just plugged in our numbers, and I got 2 is equal to k. So our equation is y equals 2x. And then I just plugged in 8 to get when x is 8, our y is 16. Let's move on. So for these ones, for the data in each table, tell whether y varies directly with x. If it does, write an equation for the direct variation. So for this one, we're going to take y over x, and for each one of these ordered pairs. And then if it comes out with the same slope, then we're going to have a direct variation. So for this one, we take negative 2.5 over 2, and you would get negative 1.25. And then the next set, we would take 8.75 over negative 7, and we get negative 1.25. And then for the next one, 6.25 over 5, and we get negative 1.25. So this is a constant rate, so we can make a direct variation equation, and it would be y equals, and this, since this is our constant rate, it'd be 1.25x. So this is our equation. I want you guys to try to do number 9 on your own and see if we can come up with an equation. Then we'll come back and see if we get the same equation. Okay, I'm back. You can see what I did. When I did this y over x for all of them, I got 1.2, 1.2, and negative 1.2. So that is not a constant rate since this one is negative. So no, this one cannot be direct variation. Hopefully you guys got that. Let's move on. So for this number 10, an equilateral triangle is a triangle with 3 equal sides. The perimeter of an equilateral triangle varies directly with the length of one side. What is an equation that relates the perimeter P and the length L of a side? What is the graph of the equation? So we need to come up with an equation. So the perimeter P is going to be equal to something corresponding with the length. So if we have a triangle that has equal sides, so if this is L, this is L, and this is L. We have 3 L's. So as the perimeter changes, the length, you have 3 side lengths of the same length. So it'd be P equals 3L. So let's graph this now. I know you don't have a graph, so let's just draw one together. So let's label it. So this axis will be side length, and this axis will be perimeter. So when our side length is 1, let's do 1, 2, 3, and 4. I think that would be good. Let's just start making some tick marks up the side. I'm not sure how many we'll need, but we'll figure it out. Okay, so when the side length is 1, we just put 1 in for L, and it would be 3. 2, 3 times 2 is 6, so go up to 6. 3 times 3 is 9, so go up to 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. And then 4 times 3 is 12, so 9, 10, 11, 12 would be right there. So this is our graph of the direct variation. And again, that will go straight through the origin of 0, 0. Hopefully you guys understood that one. Let's move on to our last couple. So for these ones, tell whether the two quantities vary directly. Explain your reasoning. So for number 11, a recipe that calls for 2 cups of sugar for each cup of flour. So we have to decide if it's going to vary directly. So for every 2 cups we use a cup of flour. So it goes up 2 cups every time, and it goes up by 1 cup. So it does vary directly because every time you use 2 cups, you use 1 cup of flour. So yes, it varies directly. And for our reasoning, we can say for every cup of flour, we use 2 cups of sugar. Hopefully you guys understood that. Let's do number 12 and see if we can figure that one out. So for number 12, Jackson's age and Dylan's age. So we have to see if it's a direct variation, if it has the same proportion every time. And so every time, if Jackson's age goes up 1, Dylan's age would go up 1. Or if Jackson's age goes up 2, Dylan's age would go up 2. So it does have the same constant, but it won't have the same proportion every time. Because if Jackson's age is 5 and Dylan's age is 7, and then it goes up 2, it'd be 7 and 9. Wait, 7 and 9. But it won't be the same proportion because 5 over 7 and, no, sorry, my bad. 7 over 5 and 9 over 7 is not equal. They are not equal. So it is not a direct variation. So no. Because the ratio of their ages isn't the same. Hopefully those made sense to you, and bring these notes to class tomorrow and we will check them off, and hopefully you guys can get started on your homework and get it done in class. Have a great night, you guys.